Good morning, everyone. I loved the keynote session, and so I have an idea. So when I say hello Stockholm, you say good morning. Okay, but I was afraid of miss saying it. So hello Stockholm. Hello Stockholm. Woo! It's a pleasure to be here. My name is Cedric, and I want to just say a big thank you to Matthias and the organizing team and all the volunteers for making this event happen. I think it's very amazing. And happy to be here in Stockholm. So my name is Cedric, and yes, I'm from New York, and so I appreciate you guys having me in Sweden. I love Sweden, beautiful, beautiful country, beautiful city. But today, I really want to talk about the rise of local AI, and especially as we'll see today, local language models. But what I've noticed recently is that, especially with, I don't know if you saw this the other day, but there's actually a new kind of policy change, at least for OpenAI, where now they have to essentially hold on to your data and hold on to your records, even when you're using the API. And so I just have a question for you. How many of us are interested in local AI or have policy restrictions in using AI at your organization? Okay. I didn't think it was going to be everybody, but that means we're all here at the right spot. So coming back to the presentation here, essentially, so the big idea here is, yes, you might have used Copilots or you might have used ChatGPTs, but you might have issues either with your data going to one of these third-party APIs, or, for example, you're paying for these services. And why do that when you could run models on your own machine? So what I do at Red Hat is, with open source technology, we help organizations and developers run their own models. And so what we're going to see today, with all the live demos that I didn't record, so I hope that they work, is how you can run models completely free locally on your machine, keep everything on premise, and as well as actually take that and scale that up with Kubernetes. So I'm an open source engineer. I'm also a developer advocate at Red Hat, and I organize the Kubernetes Community Day in New York as well. So I'm going to show you the pathway in going from your local machine, running these models on premise here, but also taking this and maybe scaling this up, deploying this on a cluster, and then adding capabilities like RAG, like agentic, and much more. So let's go ahead and hop in. So we've got a lot to cover today, and yes, it's true. You can run your own language models powered by open source technology, and they're really, really good. I don't know if anyone heard about this, but the DeepSeek, the newest release, actually outperformed Claude 4, which is pretty impressive. And because of that, there's a lot of open source tools that you can use. You might recognize some of these logos, for example, Ollama or VLLM, that allow you to run these models. The big issue, though, is that there's over 1.5, and I just checked today, there's 1.7 million models that you can get from Hugging Face, which is the GitHub, for example, of AI. But the next step is, hey, let's say I had that model. How do I integrate that with my data, with my code base? And for the agentic demo that you're going to see today is, how do I use things such as LangGraph or MCP in order to make the calls from a local model to be able to retrieve information, for example, from a database and pull that back in. Now, since that's the theme of today's workshop and the session today, I want to show you a quick example of kind of running a local model so we can see this in action. So let me go ahead, and I've got just an HTML page that I want to show you here. Is essentially going to be listening for a model that's running on port 8000. Hey guys. And the question we're going to ask is, hey, what celebrity does the person in the camera look like, right? So I'm going to show you this command in more detail later. What I'm doing is using Llama C++ essentially to start up a local API. You can see, hey, I just made a request to just do a health check, make sure everything's working. And what we're going to do is we're listening for this local model that we have running. We can see it's loaded into the model. We can see that we also have, for example, support for the GPU that I have on this machine. And let's go ahead and check this out. So this person is Beyonce? Justin Bieber? Okay. Does anyone want to volunteer to see what celebrity they look like? Yeah. Do you guys mind coming up real quick? I think my dark hair isn't working, and I don't look like Beyonce. So let's see, my friend. Dwayne Johnson. Yeah. Yeah. Nice. Okay. Thanks, man. I appreciate it. So this is what we're going to see today, but we're going to see more the the practical side and some more fun stuff. But this is the whole premise of hey, running local applications with local models to then say move that into Kubernetes or wherever you actually deploy your applications, but not having to rely on those third-party services. So let me hop back over here, and I'll kind of show you today what we're going to be learning about. And if you want to see the slides, feel free to check that out as well. So essentially, you're going to learn about, hey, how do you run your own LLMs? How do you run your own AI models? Not just text, but as we just saw, also maybe, for example, photo and audio. And the big question is, when the world of open source, you've got so many options. You've got Llama, you've got Qwen, you've got DeepSeek. So how do you choose the right model? And then you'll learn how to integrate that into your existing setup, right? As a developer, maybe you want to use a Copilot, but you can't be sending that data somewhere. So you'll learn how to use a local code assistant, but also, hey, how do I connect with, say, Postgres, for example, in my databases and where I want to pull that data from. And we'll do 3 different demos. Hopefully, they all work. The first one, good to go. Thank you, man. And I'll also have this link at the end, so if you didn't catch the slides, no worries. The big question, right, why is everyone starting to run their own AI models? Well, as a developer, speaking from experience, right, if I have something running on my local host, say, for example, when I'm working with MySQL or a Neo4j, I can spin that up in a container and connect to that locally. You don't have to worry about authentication. So it's a very easy way to quickly get started. And you also have the ease of control and customization. So let's say I'm testing something against GPT-4, for example, and they make an update, and they suddenly aren't supporting that version of the model, right? Maybe I have to make changes to the prompt template or the way I do function calling or all of these different things that are beyond my control. So if I have the ability to self-host and run this, I can do my own versioning. I can control how big the model size is, so I have effect on the cost, for example. And for my organization, the big thing is, hey, I'm not sending this data to another server. We're keeping this all local. And the models that we're going to be using today are quite powerful, but the stack to do it is a bit overwhelming. So this is last year's machine learning and AI and data landscape of all of the different options there are in order to, say, serve these models, monitor, to be able to do analytics, to be able to do so much more, right? But you probably might feel like this sometimes, right? Where it's just a little bit overwhelming. So I'll show you the open source projects that I use that also a lot of developers in the community are using that maybe you've already used before, so that you don't feel like this where you're trying to, hey, download these models from different repositories and then configure the runtime to serve them and the correct prompt template so it's not hallucinating or giving you 4s the whole time. And so we're going to make this easy for you, and I'm going to point to all the repositories and show you this in real time. So what open source technologies can we be using today? So who knows what game this is? Sweet, my people, my people. Yeah, it's my favorite game. So as you know, there's a lot of different characters in Super Smash. Maybe you're playing Kirby and you keep jumping away, right? Or you have Samus and you've got the little laser. How it works in the game is also similar to how it works in this field as well, because every player in the game has a different power, or a different kind of specialty. For example, let's say that we're using Ollama, right? It's great for local development, but you're probably not going to take Ollama and scale that up because of the backend and because of concurrent request and batching, right? That's when I would get to VLLM, or maybe I'm just using Hugging Face as a way to download and store my models. So there's different options for different use cases. How many of us have heard of or used Ollama? Perfect. Cool. All right, I'll skip past this. All you need to know if you haven't used it before is that it's created by a former PM of Docker. So that's why it's very similar in the UI of, hey, Docker pull, for example, and Docker run my model is going to be pretty much same with Ollama. And you have this concept of a model file. So a kind of simple file in order to point to a specific model, add specific parameters, prompt template, and you've got kind of this model server approach. So I'll quickly show you what this looks like in action. But let's say I'm hopping out of here. What I was using there was Llama C++, which is kind of the underlying bare bones. You could think of it as the JVM for working with these apps, or working with these models. Ollama, just kind of a abstraction for doing that. So you could, say pull or run a model, quite simple like that. But let's go up a little further, because let's say that we're using models in a distributed fashion, right? We have these GPU accelerators that we want to use. This is where a project called VLLM actually comes into hand, because it started off as a research project because traditional frameworks for serving models weren't very memory efficient. So you need to utilize all of the GPU blocks and the resources for the hardware that we're paying so much money for, right? And so what they saw is significant improvements from, for example, the Hugging Face TGI transformers runtime, for example. And so this is what Google and AMD and Meta and a lot of other organizations are using in order to serve their models in a distributed fashion. And I'm going to show you how to use it on Kubernetes. But just to show you really quickly these projects as well, let me hop over to VLLM and show you just kind of what it's about. So quite a popular open source project. You can check out the docs online. But if you haven't heard of it before, I would say check out the performance benchmark. And so this is about a year ago. You could see that you were achieving essentially almost 3 times higher throughput than other type of similar methods in order to serve models, right? So this is Llama 8B on a H100 GPU. So you save resources and memory, and you also increase throughput. So let me go to the next one here, and I'll show you what we're working on here at Red Hat in order to kind of make a more transparent and accessible way to work with models, but also to use not only OLLama's registry, but you can also use, for example, Hugging Face or any OCI registry. And so this is called Ramalama. And I'll show you this in a little bit. But in addition to supporting Llama C++, is that backend, you also get support for VLLM and also Whisper, for example, if you want to use audio models. So it's just a more open and registry agnostic way, because we were trying to make PRs to OLLama, and some of them weren't coming in. So we're like, hey, we'll start this project. And so we'll check this out as well. And for my developers in here, how many of us are developers? I'm assuming. Sweet. Okay, perfect. So for developers, what's happening now is that, hey, you might be asked to create or add generative AI features to an application, but you're not a data scientist, right? You're not familiar as well with using these libraries or serving models, and this can all be kind of abstracted with containers. So what we do is we package a model into a container, just mount it to that container and use the runtime that we need. And then you can essentially run these models in containers. And when you're ready to scale things up to, say, your cloud native environment, it's already in a container, so you have that same consistency. So we know about the tools, right? What models should we be using with them is a good question. As you know, there's been an explosion in the open source landscape. Essentially, 2-3 years ago, there were no open source models out there that could really stand against, say, for example, the ChatGPTs. Now we've got DeepSeek, we've got Qwen, we've got all of these other models that essentially can almost perform the same on benchmarks that you could download and run on your own infrastructure. So you don't want to be back to here again. And so I'll make another video game analogy where, hey, for example, in Mario Kart, different players can do different things. And so which model should you select? It's a good question. But generally, what we typically see is that, hey, if you want a reasoning model and you want the highest, say, performance in pulling and retrieving your information, you could use DeepSeek. Or maybe it's Granite for enterprise tasks and understanding where the model's data has been licensed from, or Mistral or Llama. But there's plenty of options out there. And just to illustrate how many models are out there, let me go to the models page right here on Hugging Face. So huggingface.co/models. I took that screenshot like a month ago, and there's already 200,000 more. But just to show you what you can do, I would go to the left side here where you can actually learn about, say, if I want to classify text or if I want to do translation. There's also models that have been fine-tuned in specific languages. So if you want a Swedish model, then you could look for different benchmarks there. Maybe it's audio, or maybe it's computer vision. Whatever you want to do, you can definitely check it out from here and say, for example, figure out which model you want to use. Now, we'll talk a little bit more about models and quantization in a little bit, but let me head back over to the slides, and we'll keep going through here. So Not all models are the same. What we noticed in that first demo was that we were using a vision model, for example, but the vision model is combining the modality of text in order to process both of those. So that's what's known as multimodal. And unimodal, for example, is that embedding model that I just showed you on Hugging Face is going to convert your text into vector embeddings, right? So that's essentially going from one data format to another, and that's unimodal. But traditionally, you're starting to see most models, such as the new Llama models, are by default multimodal, so you can use them for vision, parse documents, et cetera, et cetera. And just in case you want to know about the naming convention, well, here we are. So essentially, you've got the family name, so the type of model, maybe it's IBM's or Mistral's, for example, and the actual architecture. So we're on 3 or version 4. But the big thing you need to pay attention to here is the base versus instruct. So base models haven't been fine-tuned for the specific question and answering that you're probably going to want them to do. So they're going to essentially sprout gibberish, and you might have experienced this before. So you want to make sure that, hey, you're using an instruct or a tool calling or an embedding model specifically, and see that when you're actually looking at the model card. And then model version, mixture of experts, for example, and so on. So if you want to deploy one of these larger models, though, right, you want the model with the best benchmarks, right? Maybe bigger is always better, but if you want to do that, you're going to end up like this, where laptop's on fire, or you need this huge type of rig and GPU acceleration. Neither of those is ideal. So how do we fix that? Has anyone here heard of quantization? Fantastic. So quantization was traditionally a machine learning type of activity where you're essentially applying compression algorithms in order to reduce the numerical precision of the model. So a lot of organizations, maybe it's Meta or something like that, are releasing their models as open weights, not open source, but open weights, as you get the output, but not the training data and the secret sauce, right? They give you that output, but they're traditionally releasing it as floating point 16, which has a lot of capabilities, but for a rig like this, my MacBook, I'm going to want to run something that's more compressed. A .zip, a .tar is a good analogy. I actually try to say from a .raw to a JPEG. Right? So you're converting high precision weights and this accuracy to something smaller like this, and it reduces the memory footprint. So the benefit is that, say for example with Llama 3.1, we were able to compress this to essentially go over 2.4 times of a performance speed up and reduce the model size by 3.5. So it's a way to, say, take a model, be able to compress it, be able to run it in IoT environments on a MacBook like this, and it's a way to save resources if you don't have that much hardware available. And there's an open repository of these models. So if you check out the QR code, it sends you to Hugging Face. And what we've done is we've essentially taken all of these open source models, for example, from Llama, Quinn, Gemma, etc., done this compression using smooth quant or sparse GPT, these algorithms, and we've kind of just released these out there for you to use, say, for example, with VLLM. And be able to cut your hardware cost in half. So this is for the later part when you're kind of already trying to scale things up. But we've got the engine, we've got the model. Let's talk about the data, because if you have, say, for example, PDFs or websites, you probably want to chat with it. We're going to show how to do this locally to be able to chat with PDFs. And I'm going to show you the source code for all of this. I think we're doing good on time. We're also going to show code assistance. So let's say I have my IntelliJ or my VS Code, and I want to be able to use a local model. So we're going to check that out. And then finally, it's going to be about building applications. So this isn't just using the models, but this is adding a model to your application using LangChain or some other framework in order to add those AI capabilities. For example, audio to text or GraphRag or agentic function calling. So we'll check this all out today. We good to go with the first demo? Sweet. Okay, very cool, very cool. So let's do it. So the first one I'm going to show you is model serving in RAG. So what I did earlier today is I went to the website and I scraped the schedule. And let's say that we want to make some type of application or allow our organization or allow you to be able to chat with that website. We talked about RAG earlier in the keynote, which was a great primer for this specific demo, which is fantastic. So let me go ahead and head over to this tool that I'm going to be using. So has anyone tried out Podman before? Sweet. All right. Thank you so much. That's my people. So Podman is a alternative to Docker, essentially. It's an open source alternative to Docker desktop. And so you can check it out online. This is a CNCF project. And this allows us to run our containers and connect to Kubernetes environments. But what I'm going to be using it for specifically is for this extension called AI Lab. So you might have used Docker before, or sorry, Ollama before. What's happening is we're essentially using the same underlying runtime, but we're just doing this in a containerized fashion. So I've got some models here. I've got this Granite 3.3, but I also imported one from Hugging Face. So what we're going to be doing is using this DeepSeek R1 that's been distilled into Qwen. So essentially, distillation is when you kind of take the capabilities of a teacher model and pass that into something smaller. And so there's a lot of ways to do this. But essentially, you could distill this into Llama. You could distill this into any smaller model because the original DeepSeek is, I think, 400 or 600 billion parameters, which the laptop would explode. It would be a big hazard. But what I can do here is actually just run it as a container. And I've actually already got this running as a container. We can see it's running here locally on this specific endpoint. We've got the model path, GPU inference. And as a developer, I've got the Swagger interface in order to quickly, hey, test that everything's working. So let's say we want to do completions post request to that API. What's the capital of France? It's Paris. Good to go. So that's running locally, and I want to show you the first tool that we're going to be using today, which is Anything LLM. So Anything LLM is also similar to Open Web UI, which is a quick and easy way in order to essentially connect to models, whether it's local or remote, and be able to use my own data or, for example, my own agentic functionality. And so I'll show you how this works real quick, but I go to the settings here, and I can connect to any OpenAI provider or, for example, ChatGPT or any of the other providers for models that might be third party. But what I'm going to do here is I'm just copying in that endpoint, and we can set some parameters for tokens, temperature, etc. And we're also going to be using a vector database in order to store the embeddings for that PDF. So when I convert it into embeddings, and I can use different providers, third parties, but also local, it's going to essentially take that document. And if we ask a question here, so I'm going to say, hey, what's the keynote speaker for AI Focus? Traditionally, a model hasn't been trained on this information. It's not going to have an answer. And here you can see what's happening is this is the reasoning capabilities, the thinking capabilities of the model. So after this, you see, I don't have information about the keynote speaker, right? You should check the website. Not helpful, not helpful. So what we've done here is I'll go over to this question answer with RAG, and we can see that I've uploaded the JFocus schedule. So if I go over here, bam, all these lovely speakers, good to go. So, oh, who is this one? That's cool. And so what I've done is I've uploaded that, and when I uploaded it and converted it into those embeddings, maybe you want to use GraphRag as an example or just this default RAG capability. Who's the keynote speaker for AI Focus? So now when we ask this question, what's happening is we're making the what's happening in the background actually is it understands it's been provided that context, right? So there's going to be 4 different examples of context from that PDF that are similar to this question that I asked, right? Oh, I cannot answer. Oh, did I pull the JFocus schedule? Maybe I did. Hold on, we'll see. Oh, interesting. Let's see. Is Cedric speaking? We'll just ask real quick. So, okay. Cedric Vanderhorst. Maybe I pulled the wrong schedule. But essentially what happens here in the background is when I go over here, so I can click settings here, and I can actually kind of adjust this. So it's like, hey, I'm going to use this prompt template every time I ask a question, right? I also have this vector database. And so when I'm pulling and I'm retrieving that information, it's going to add the 4 most common or most relevant entries. And this is kind of the default algorithm you can use, but you could modify this, say I only want the top 2, or however you want to pass this in by search preference. So that's a quick example of RAG. I don't know if it really worked. I apologize, but good thing there's other demos. So what I want to show you is, let's hop back over here. And let's check out the next example. So RAG, everyone's used it. Code Assistance is quite popular. I'm assuming a lot of us here are using Code Assistance, vibe coding, and you know, keep vibing. I love the word. So if we've got this model still running on our local host, right? What we're going to do is I'm going to use an extension here that's called Continue. So Continue is just an open source way to call a model and be able to integrate this in my IDE. So we can see here, hey, it's just you know, available on IntelliJ, available on the VS Code Marketplace in order to connect to models remotely and also locally. So what I'm going to go ahead and do here, and this is the repository I've linked in the slides, is we've got some, say for example code, but also configuration.json. So let me hop back over to, so I opened up this Continue extension. I've got Copilot, right? But this is going to be sending my data to some type of third-party API. What I want to do is connect to something local. So maybe this is through OpenAI or one of those other third-party providers, but I'm just going to use the kind of default OpenAI API spec, right? So what I'll do here is I'll just come in here, which is the configuration.json, and I'm going to add the port where I'm actually hosting this model so that when we come back here, what I'm able to do is, let's say, for example, I want to add context. I can add files, for example. I could, you know, index the entire code base, for example, or I could say, what's happening in this file, right? So this is going to, let's see, I can highlight it and add it as context. Add docs, right? So it's going to make a post request to the, oh, so it's doing the thinking. Okay. So essentially, it would make the post request to that model that's running locally and be able to chat with this model. But what I'll do here is I'll just add it again as context and say, what's happening in this code? So cool. I think I need to refresh something. Let's see. So I've got it. Okay, temperature 558. Okay, that's why. Good to go. All right. Let's see. Live demos. All right. Let's see. You also have the ability to just chat. Give me a fast API spec, and you'll see that the model is going to first do the reasoning, and then it'll actually give you the output. While we're waiting on that, let me just make sure that it is running. Yeah, okay, so it is running. Sorry, guys. All right, let's execute it. Oh, okay, it's not running. That's why. What might have happened here is the amount of RAM that you have on your system is an impact to which models you can run. So this one is a 8 billion parameter model. So let me go ahead and stop it, and I'll restart it. I can also show you that, hey, if you want to import a smaller model, 500 million or something like that, then you can also do that as well. Computer's being a little iffy today. Sorry about that. But essentially, that's the way to start integrating it into the IDE. So I'll try this one more time. So we'll create this service, and let me come over to add chat model configuration. Replace the port one more time. Fingers crossed. All right, so I add in the file that we want to call. So this is the context here, and then this reasoning models. There we go. Yeah, so just a little weird issue there sometimes if your computer is running low on RAM. And we're good to go. So you can kind of get the answers that you need, all locally, all open source, using the extension Continue. But there's also other open source alternatives out there. I just use it because it's the most popular. Now, coming back to our demos here. Now, a lot of us have been using or wanting to use agentic capabilities, whether it's through MCP or existing frameworks, because function calling, the actual act of, hey, I'm going to give you this API, and I want you to make these calls has been around since 2023. Now, it's just being standardized with MCP, but it's actually been around for a while. And what I want to show you here is let's go beyond just running things locally and actually put this in a Kubernetes environment. So what I have here is OpenShift, and OpenShift allows me to, hey, take my applications, containerize them, and deploy this with all this RBAC and enterprise features. And so what I'm going to do here is what we have is the local application. So if I come up here, we've got a back end and a front end. So the back end is essentially going to be using Lang graph here, and Lang chain, sorry, to do different calls to these APIs. So we've got a Python tool, we've got a DuckDuckGo search tool, and we're just adding these here as annotations. So this tool for Python repo, or getting the stock price or doing a search, and then we're just putting this together and letting the model know that, hey, you have these capabilities, and to use the React agent, so the React framework. So essentially what we've done is containerize this so that we can deploy this in a Kubernetes environment, or maybe, for example, locally. And I'll show you this front end here. So the front end, quite simple. It's going to allow us to use these tools. And what I'll ask is, what is the weather in, say, for example, Stockholm? But what I want to do at the same time is show you the logs here. Ooh, we've got a lot of fun stuff happening. Sorry about that. I just noticed the clusters updating. So that's my favorite thing to happen. Let me come back here. 1 second. Okay, there we go. We got this back in. I'm just going to show you the logs of this container so that you can see it happening in real time. So we asked the weather in Stockholm. The model that we're using is Granite 3. You're going to need a model that's been trained on tool calling to be able to do this. And we can see that it used, say, for example, the DuckDuckGo tool in order to pull the weather. So we can see tool call detected. What are the arguments? Weather in Stockholm. It's going to use DuckDuckGo, and it's going to pull from duckduckgo.com weather in Stockholm, get that response back, and the model is going to do the parsing to get that response back, right? So, a quick way to kind of start using tools and to deploy this on Kubernetes, right? But what we have here is just the 2 containers that are powered by an AI model, right? But to actually use the AI model on Kubernetes, we're going to use, as I talked about again, VLLM. So VLLM allows us to, say, use this in conjunction with Kserve. Kserve is a way to dynamically scale our models, whether it's LLMs or other types of predictive AI models up and down, so that, hey, if I have more requests to this model maybe in the morning, it can scale that up and dynamically scale that back down. And so essentially what I have here is VLM perhaps running as a container. But the way we actually can do this, say, for example, in an organization, is to use what's known as models as a service. So models as a service, say, for example, is a way to, within your organization, take these models to be able to serve them and allow users in the organization to be able to use them. So what I'll show you here is this is a kind of internal thing that we have, and it's pretty cool. But let's say, for example, our platform team has a request to start enabling users to use these models internally. Well, what they're going to do is, say, download these models and be able to serve them using VLLM as a runtime on Kubernetes, so that I, as a user, could, say, for example, use DeepSeek distilled into Qwen. I could call it Qwen demo, and be very careful here. For me, myself, I guess, because I'm sharing an endpoint. But essentially what I could do is, hey, I'm going to start using this in my application. Instead of doing localhost, right, I'm doing a local call, to this model running remotely with this, for example, API key. And that's a way for our organization to then go run our models in a production fashion, but still keep everything on premise. So this is just a kind of example pattern of how to do it. There's going to be different solutions for different organizations, but I think it's a great way to do so. Now, I'll come back over here, and what I want to show you is that, hey, let's say we're running one of those models. Maybe it's the 70 billion llama, for example, or this DeepSeek. What's really important is that, hey, if I want to compress this and be able to serve it and be able to scale it up, quantization is going to be there for us. So let's say, for example, that we have a 109 billion llama 4 model, right? If I'm going to serve this, by default, those release weights floating point 16, I'm going to need 3 A100s, right, to be able to serve a model that has a parameter size of 220 gigabytes. By compressing this, as we've done, for example, locally here, or if we scale this up, we can significantly reduce the amount of GPUs so that we can kind of bring this up, scale this up. But how do you know how to compress and quantize? Well, there's a library called LLM compressor. If you already know which model you want to use, and maybe it's not already compressed. Or say you take your model, you apply some type of compression with this library, and then you can serve that with, say, for example, VLLM or Llama C++, Ollama, and integrate that into your application. And so you can use, for example, this open source project to do that. But the great thing about open source is someone might have already done that for you, right? So I'm going to show you a popular way to access these models. So I'm going to go over here to Hugging Face. For example, this is the model that I actually downloaded, and I served this. And so you can see you've got all these different quants here for different types of algorithms. But it's quite easy to, say, for example, download this as I did in a 4-bit fashion. If you want to do that, I recommend that. And I also recommend, quick shameless plug here, is the Red Hat AI. So there's all these different validated models, for example, Gemma, Llama 4, Mistral, whatever you want to use. And so if you know which model you want to use, it might have already been compressed for you. But when you're using everything local, whether it's with Ollama or with this tool that I've been using, these models have already been compressed, and so they're good to go for you. So with that, I want to just end on a note where, hey, if you want to build these applications locally, what I want to show you is this recipe catalog. So a lot of us have maybe built applications from scratch with Gen AI features, but you don't have to reinvent the wheel. So this recipe catalog, part of the Podman desktop, it has a lot of different fun recipes, but I want to try this one lastly before we close out. So this is audio to text, and if I open this up in VS Code, I can show you that, hey, what's happening here is we've got kind of this quick and easy Python file that's connecting to a model running on port 8001. That's essentially going to allow us to upload some type of MP3, a wave, and then process that with the model that's running locally, and we can containerize this. So what I'm going to do is I'm just going to start this recipe. So it's just going to go ahead and build this image, run it as a container. And let's go ahead and try this out. So it's running locally on this port, and fingers crossed, sweet. So what I want to do is, since we're in Stockholm, could I have a volunteer who speaks Swedish? Because what we're going to do is I'm going to speak in English, and the model that we've used has been translated, tuned for 80 different languages. So if anyone wants to volunteer and speak Swedish, we're going to see if it'll translate it well and test the AI. Okay, thank you very much. Sweet. How are you?
Well, Swedes never volunteer for anything, so.
Feel free to say anything you want.
Okay.
I'm not going to know what you're saying.
Ja, det här var en trevlig konferens. Väldigt spännande och intressant föredrag, tycker jag.
Sweet. Thank you. I appreciate you. Let's see how it works. Okay, we've got this file here, and I'm going to go back to this this application that we have. Actually, I can just drag it in. That's a little easier. And let's see. Fingers crossed. So the model is running locally. Let's see what it parses. I don't know. I'll just zoom down here. Let's give it a second. Okay. It might have not picked up too much on it. Did you say? I guess so. Well, still a cool little demo, and if you want to try this out on your own machine, feel free. But thank you. Awesome. So that's just a quick example of how to build these applications. There's RAG, there's GraphRag, and Agentic, but this is definitely my favorite one. All right. With that being said, the Agentic application, if you want to kind of replicate this on your own machine or try out the repository, allows us to use both the front end, the back end to make calls to an LLM. And the reason that we have MCP, if you're going to go to the other session, I think my buddy is after me, it's going to be great, is that, hey, traditionally I'd have to write the function call to make all of these requests to those APIs. But what if someone already did that for me, or if there's a way to standardize that? And that's where it really comes into play. So hope you stick around for the next session. Today, you learned about running models locally. I told you a lot, but to recap it, you can connect these local models with your data interfaces for RAG, code assistants, and your IDEs, and you can build these cool applications and scale things up because, A, if you're working in containers, just take that to Kubernetes. And to close, I'm going to just show you the source code again for the repository. And if you want to check out the session slides, feel free to do so. If you had fun, I hope you can rate the talk, and feel free to connect on LinkedIn. But I'll be around the conference if you have any questions. I'd love to talk about all things open source AI, about the tools you can use, and I hope you guys have a great rest of the conference. Thank you so much. Woo.
Any more questions from anyone? Yeah, sure.
So thanks for sharing all these interesting parts. I'm a little bit curious. You're talking about running things locally, and of course my local laptop will not be able to do the full open AI chat functionality. So if you scale from a local laptop and then up to some local machine like 500 gig Mac Studio and then next step in ladder, what kind of capabilities would you expect to get, and what would you expect not to get at each rung of the ladder? Could you expand a little bit on that?
Yeah, that's a great question. Something that's interesting is that, hey, I have a Raspberry Pi at home. I can still run a 2 billion parameter model on it, but the speed is going to be quite slow. So it's going to be, the tokens per second. But if you have a machine that just can't handle the parameter size of the model, it just won't run it, because it's just going to run out of memory. So the things that you're going to see if you go to a bigger machine, and for example, if you have like a rig at home that's running Linux, you could just run a model server on it and just connect to it remotely and just not use your own resources, for example. But you're going to have more throughput, and the accuracy isn't really going to change because that's how the model is quantized or released with the weights. So the way I kind of like to explain it is that, let's say that you have quantized to integer 8 or integer 4 or something like that, as we did. So the accuracy isn't going to change based on that. You're going to have the same results, but the speed might be different, type of thing, yeah.
Could you just follow up, at what level do you get decent code assistant? At what level do you get something you could run RAGs for large swaths of text or something like that?
Yeah, that's a great question. So specifically, it just depends on, let's see here if I can find just a code optimized model. It just depends on what model you're using, because specifically, some have been optimized for codes such as I think it's QWQ. Yeah. So for example, there's about to be a new Quen model that's specifically been optimized for coding. But the two big things is if it's been optimized for coding, and also the prompt context length. So traditionally, when I was doing vibe coding locally last year, I couldn't get good results because the context length was like 8,000 or 12,000 or something like that. But now you can get models that are 128,000 tokens, and so you get much better results because I can actually have a longer conversation and index more of my code base with the conversation using a model locally. So generally, I recommend 32 billion parameters for a model like that. That's when you start seeing good results. 8 billion, not necessarily. But I can run this model locally, but I've got probably too much RAM. So it just depends on the machine that you have, and I would recommend anything 28 billion parameters or higher. Yeah. Thank you.
Any more questions? We have a little bit more time here.
Yeah. Howdy. Thank you so much.
So just a follow up on that. If you want to run this locally on Fedora, for example, what kind of hardware should you have? Let's assume that we run that kind of 32 billion model or something like Codestral or something like that.
Yeah, that's a great question.
And what kind of GPU or MPU should you use? What's your experience?
Yeah, so I unfortunately I work at a Linux company, but I don't run Linux. But I can still answer. So my buddies who have like a 3090 or above GPU can generally run these types of models where you need that much context length. But if you're running CPU, for example, probably not. But you can also say, for example, rent I do EC2 instances sometimes when I have to do fine tuning. So if you have access to hardware like that, and you can just point to some type of I don't have it open anymore, but point to some type of model there. That would be the best way if you don't already have that 3090 or above. Yeah.
All right.
Sweet.
Thank you very much.
Thank you guys.
And this is a little token from us.